In this video, you will learn about monomial factors of polynomials. Now, as we begin, we need to understand a property of fractions. So the property of fractions we need to understand is if we have something like this, a plus b over c, that we can break apart the fraction as two fractions, where we have a over c plus b over c. For example, if we had 6m plus 30 over 6, I can break this apart as two fractions, where I have 6m over 6 plus 30 over 6. So from here, I can simplify. On the first fraction, I can divide by 6. I'm left with m over here. And then the second fraction, I have 30 over 6, which would equal 5. So what I have is m plus 5. Okay, another example. Here we have 24xy minus 36y over 12y. I can think of this as two separate fractions, where I have 24xy over 12y minus 36y over 12y. So what this allows me to do is now I can simplify. So 24 divided by 12 would give me 2 over 1, and then the y's would cancel. We have y divided by y, which would give me 1 over 1. Then I have the x right here as well. So on the top, I have 2x. On the bottom, I have 1, which doesn't matter. The second fraction, I have 36 divided by 12, which would give me 3 over 1. And then the y's would cancel. So what I have left is 2x minus 3. So this property is useful for simplifying fractions and for dividing. Here's another example where now we have more going on. We have 3a to the 5th minus 9a to the 4th times y plus 6a cubed times y squared. All of that is over negative 3a cubed. So once again, if I wanted to divide, I can break this apart as multiple fractions. Here I have 3 terms on the top, so I'm going to have 3 fractions. So be careful with the negatives. We have 3a to the 5th over negative 3a cubed, then minus 9a to the 4th times y divided by negative 3a cubed, plus 6a cubed y squared divided by the negative 3a cubed. So from here, I can simplify each fraction. So for the first fraction, the 3's will cancel. I have negative, and then a to the 5th divided by a to the 3rd. I can subtract the exponents 5 minus 3 to get 2. And that goes on the top because the 5 was bigger. So we have a squared on the top, and then don't forget the negative. All right, second fraction. 9 divided by negative 3. That would give me a negative 3, and then over 1. All right, and then we have the a's. A to the 4th divided by a to the 3rd. We can subtract the exponents 4 minus 3 to get 1, and that goes in the top because a to the 4th is bigger and is in the top. And then we have a y as well up here. So for this one, we have minus a negative 3ay. All right, so minus a negative, that will become a positive. All right, so it becomes a positive 3ay. And then over here, the third fraction, we have 6 divided by negative 3 would give me negative 2. And then the a's would divide out. Then I have the y squared right there. So what I'm left with is negative a squared plus 3ay minus 2y squared. Okay, here's another example where we are told to divide. So once again, we can break apart this as 3 separate fractions. We have x to the 4th y squared over xy plus 2x over xy minus 6xy over xy. So the first fraction, I have 1x and 1y in the bottom. So for the x's, I subtract the exponents because I'm dividing. So I subtract 4 minus 1 to get 3. And that goes on the top because x to the 4th is bigger. And then with the y's, we have 2 and 1, So we subtract 2 minus 1 to get 1. That goes in the top because the 2 is bigger and it's in the top. Second fraction, the x's can divide out. I'm left with a 2 over y. And then the third fraction, the x's would cancel and the y's would cancel. I'm left with a minus x. So my answer when I divide is x cubed times y plus 2 over y minus 6. So notice in the first example that nothing has fractions anymore. So everything divided evenly. So here for this example 3, we can say that 3a to the 5th minus 9a to the 4th plus 6a cubed y squared is divisible by negative 3a to the 3rd. Alright, it's divisible because it divides evenly, because there is not a fraction in my final answer. If it does not divide evenly, then it's not divisible. So example 4 is not divisible because of this right here. There's a fraction left over. It does not divide evenly. So we say that x to the 4th y squared plus 2x minus 6xy is not divisible by xy because I cannot divide without having a fraction. So this process is important for what we call factoring. So we need to understand how to divide fractions in order to understand how to factor. So factoring is similar to distributing. And basically it's like distributing but in reverse. So here's a quick review of distributing. Here, if we had something outside of parentheses and then 2 or more terms in parentheses, I can distribute or multiply what's outside to everything on the inside. So 4x squared y times 2x would give me 4 times 2 is 8. X squared times x is x to the 3rd times y. So 8x to the 3rd times y. Plus, multiply by the second term, 4 times 3 is 12. Then you have the x squared, and then y times y would give me y squared. So this is distributing. Now factoring is like going in reverse. So instead of starting with this and getting 8x cubed y plus 12x squared y squared as my answer, factoring is going the other way. So it's starting with the 8x cubed y, etc., and going back up here at the top. So that is my objective. So we start with this, and we're trying to pull things out so that we have something outside of the parentheses, and then we have the 2 terms in parentheses. So here is how we factor a polynomial. Let's say we had 5x cubed plus 10x squared. What we do is we find the greatest common factor of both of those terms. So the greatest common factor of 5 and 10 would be 5. And then of x cubed and x squared, they both have x squared in common, so it's going to be x squared. So the greatest common factor would be 5x squared. So from here, what I do is I pull out that 5x squared, and I'm going to have in parentheses something left over. So what I'm doing is I'm thinking reverse distributing. So what would need to go here and here, both of these spots, so that when I distribute, I get back out what I started with up here. So you can do this in your head, or you can kind of go through this process I'm about to show you. But what you want to do to figure this out is you can divide. I can divide the 5x cubed by that greatest common factor of 5x squared, and then divide 10x squared by that 5x squared. So whatever that's equal to, that's what goes here in the parentheses. So here the 5's would cancel. I have 1x on the top left over, so that's going to be an x right there. Second fraction, x squareds cancel. 10 over 5 is 2, so I have a 2 over here. So I have an x and a 2, so my factored form would be the 5x squared outside, and then x plus 2 on the inside. Now personally, when I think through this, I don't usually use this step right here. I can just think in my head right at this point, 5x squared times what would give me 5x cubed? Well, the only thing different is this 5x cubed has one more x. So 5x squared times the x would give me 5x cubed. So that's where the x comes from. And then I look at the second term, 5x squared times what gives me 10x squared. And that's going to be the 2. So if you cannot do that in your head, you can think through this process that I showed you, which would get you the same answer. And that's when you divide the term by the greatest common factor. Here is another example. We are told a factor 2x to the fifth plus 4x squared plus 12x. So to begin, we find the greatest common factor of those three terms. So looking at the number part, 2, 4, and 12, the greatest common factor would be a 2. And then the x's, they all have one x in common, so it's just going to be 1x. So the greatest common factor would be 2 times x. So that is what I pull out of parentheses, and in parentheses I have 3 terms because we had 1, 2, 3 terms to begin with. So we're thinking reverse distributing. 2x times what would give me 2x to the fifth power, and 2x times what would give me 4x squared, and 2x times what would give me 12x. So at this point right here, I could develop my solution, and this is what I normally do. I have the 2x out in front, so that would go right here, and then you have something in parentheses. So 2x times what gives me 2x to the fifth? Well, we need 4 more x's. We have 1 here, we need 5 once we multiply, which means we need 4 more right there. All right, and then we can double check and see 2x times x to the fourth, that would be 2x to the fifth power. Second term, 2x times what gives me 4x squared? Well, 2 times 2 is 4. And then x times x would give me x squared. So I can double check 2x times 2x, that would be 4x squared. So the middle term is good. And then same thing for the last term. 2x times what gives me 12x? Well, 2 times 6 is 12, and the x's are good already. They both have 1x. So 2x times 6 would be 12x. So my answer can be found by going through that process. If you prefer, you could go and to determine what goes in the 3 terms, I could take each term and divide it by the greatest common factor of 2x. So 2x to the fifth divided by 2x plus 4x squared divided by 2x plus 12x over 2x. And going through this process, you would develop the same answer. So either way, your final answer is 2x times x to the fourth plus 2x plus 6. Here is another example. We have 20a squared b to the fourth minus 30a cubed b cubed. So here we need to find the greatest common factor of those 2 terms. So to do that, looking at the 20 and the 30, the greatest common factor of 20 and 30 would be 10. And then the a squared and a cubed, they both have a squared in common. So they both have a to the second power. And then the b's, b to the fourth and b to the third, they both have 3 b's in common. So b to the third. So the greatest common factor of these 2 terms is 10a squared b cubed. So what I do is I pull this number out, so that is outside of parentheses. And then in parentheses I have 2 terms, because we have 2 terms that we started with. So the question is, what do we put there? So to determine that, I could take each term and divide it by that greatest common factor of 10a squared b cubed. And that would give me the correct answer. Personally, I prefer just doing this in my head, where I think 10a squared b cubed times what gives me that first term of 20a squared b to the fourth. Well, we have 10 here. 10 times what gives me the 20? Well, 10 times 2 is 20. All right, and then the a squareds, we had a squared here, a squared up here, so the a's are fine. But we do need an additional b to get from here to b to the fourth power. So we need one more b inside. And that would take care of the first term. I can double check. 10 times 2 is 20. We have a squared, and then b to the third times b to the first would be b to the fourth power. All right, and then second term, we have the minus, so don't forget the minus sign. And then 10a squared b to the third times what gives me that second term? Well, 10 times 3 gives me 30. The a to the third power is, we have a squared. We need to get to a to the third power. So we need one more a. And then the b's, we have b to the third out here. We have b to the third after we multiply. So the b's are fine. I can double check. 10 times negative 3 is negative 30. And then a squared times a is a to the third. And b to the third is here as well. So that second term is taken care of. So no matter which way I do this, I will get the same answer. If I divide to figure out these two terms, or just think in your head what do you have to multiply by to get back out what I started with, either way we get our final answer. So it is 10a squared b to the third times parentheses 2b minus 3a.